Squeeze a tube of toothpaste. That soft line of paste folding onto your brush is more or less how 10 houses appeared in Shanghai in a single day in 2014. A printer the size of a small warehouse squeezed out wall after wall of gray slurry, one layer on top of another, and when it stopped, a company called Winsun had the shells of 10 small buildings for about $5,000 each. 10 houses, one day, $5,000 each. Every part of that sentence is true, and yet the picture it puts in your head is not quite what happened. Printed and finished are two different words, and the distance between them is the real story of how China is teaching machines to build homes. In the next few minutes, you will see exactly what a printer can do in 24 hours, what still takes weeks, and how one villager in northern China ended up living with the answer. Start with the machine. Winsun, formerly Yingchuang Building Technique, spent years developing a printer nearly 7 meters tall, 10 meters wide, and 40 meters long. It does not look like a printer. It looks like a gantry crane parked over a workshop floor. A nozzle runs back and forth on steel rails, laying down a thick paste of cement mixed with sand, glass fiber, and ground-up construction waste. The recipe is the quiet genius of the whole system. China produces mountains of demolition rubble, and Winsun's idea was to crush yesterday's buildings and squeeze them back out as tomorrow's walls. Now here is the part most of the headlines skipped. Those 10 houses were not printed on their own plots, rising out of the ground like sandcastles. The walls were printed as flat panels in a factory, one section at a time, in less than 24 hours of machine time. Then trucks carried the pieces to an industrial park in Shanghai, where crews fitted them together like very heavy furniture, and that $5,000 price bought a bare concrete shell. No wiring, no pipes, no insulation. All of that was added afterwards by hand, the old-fashioned way. So the honest version of the claim goes like this. A machine can print the structure of a house, the heaviest and slowest part of the job, in under a day for less than the price of many used cars. The rest of the house still runs on human time. If you enjoy watching enormous machines quietly change how ordinary things get made, consider subscribing. Stories like this one are exactly what this channel is for. Because Winsun was only warming up. In January 2015, the company unveiled 2 new printed structures in Suzhou Industrial Park, west of Shanghai. One was a 6-story apartment block of roughly 1,100 square meters, stacked from printed panels and reinforced with steel. At the time, nothing printed anywhere in the world stood taller. Beside it sat a full printed mansion. The company claimed its process saved 60% of the material, 70% of the time, and 80% of the labor of conventional building. Those are the builder's own numbers, not an independent audit. But the buildings are real. You can walk up and put your hand on them. A year later, a different Chinese firm attempted the thing Winsun had skipped, printing in place. In 2016, a Beijing company called Huashang Tengda put up the frame of a 2-story villa on site, threaded the plumbing through it, then ran a printer over the whole structure, its nozzle burying the reinforcement in fresh concrete wall by wall. 45 days later, Beijing had a 400 square meter villa with walls a quarter of a meter thick. The builder said seismic testing suggested it could ride out a magnitude 8 earthquake. 45 days is obviously not one day. It is also a remarkably short schedule for a villa that size, delivered with hardly a bricklayer in sight. By then, the machines had started to travel. In May 2016, Dubai opened what it billed as the world's first printed office building, a curved pavilion of about 250 square meters. Its components were printed in 17 days on a wind-sun system, shipped over and assembled in just 2 days on site. The total cost came to around $140,000 with one printer operator and an installation crew of 7, roughly half the labor cost of a conventional build, according to the officials who commissioned it. But demonstration projects are easy to admire and easy to doubt. A pavilion in a business district is not a home. Nobody wakes up inside a press release. Which brings us to a village called Wujiazhuang. Wujiazhuang sits near Zhangjiakou in Hebei province, a few hours northwest of Beijing. In 2021, a villager named Zhao Shujuan asked a team from Tsinghua University, led by architecture professor Xu Weiguo, to rebuild her aging farmhouse with printers. This time there was no factory and there were no panels on trucks. Robotic arms were set up on the plot itself, and they raised the foundations and the walls layer by layer in smooth curves, pressing a woven pattern into the outer face as they went. The vaulted roof sections were printed separately and lowered on by crane. The whole build, 106 square meters with 3 bedrooms, was completed in about 2 weeks. 2 weeks from an empty plot to a finished village house, not a day. But look at what happened to the labor. A few machine operators, a crane, and a professor's team stood in for most of a construction crew. The neighbors were openly skeptical while the robots were running. The finished walls, solid and curved in ways a village brick crew would rarely attempt, changed some of those minds. And Zhao got a new 3-bedroom home printed onto the spot where her old one had stood. If you are curious about where machines like this show up next, subscribing is the easiest way to follow along. There is a lot more of the built world left to explain. Here is the wider frame. China is the natural test bed for this technology because no country builds more. In the most recent global ranking of the 100 largest construction companies by revenue, firms based in China filled 7 of the top 10 places, and together they earned just over half of everything that list of 100 giants brought in. And yet, even in China, printed homes remain rare. If the machine is this fast and this cheap, why is your street still built by hand? Part of the answer is paperwork. Building codes in most countries were written for concrete poured into molds and bricks laid one by one. A printed wall is a new kind of structure, so engineers need new standards, inspectors need ways to certify it, banks want proof before they write a mortgage on a house squeezed from a nozzle, and insurers want a track record that simply does not exist yet. None of that moves at printer speed. The other part is arithmetic. The printer attacks only one slice of the bill. Land, groundwork, windows, wiring, plumbing, kitchens, and finishes still cost what they always cost, and they still take the time they always took. Printing compresses the shell, and the shell is only part of what you pay for a home. That is why a $5,000 shell has never yet meant a $5,000 house. But notice the trajectory. In 2014, 10 rough shells in a day. In 2015, a 6-story block. In 2016, a villa in 45 days, and an office exported to another continent. In 2021, a 3-bedroom village home finished 2 weeks after the robots arrived. The single day was never really the point. It is a marker of where the ceiling sits, proof that the heaviest, slowest part of making a home can now come out of a nozzle while a couple of technicians watch. Tomorrow morning, when you squeeze that tube of toothpaste, look at the line it leaves behind. Somewhere in China, a nozzle the size of a truck is drawing that same line in liquid stone over and over, and the only open question is how long the rest of the house takes to catch up.